Welcome back to another box mod part kit video. This is a new part kit I'm developing for an OKR T10 pass-through device. It's powered by, right now, a laptop power supply, but hope to get a desktop power supply finished soon. Put onto the parts here. We got a standard Hammond 1590A aluminum enclosure, the 0.36 inch voltmeters that I have with all my kits, Fat Daddy Vapes 510 connector with a locking ring, standard anti-vandal fire button. The rubber grommet here is actually for where the wires go into the box, so we don't mess up the wires or anything. These are two 5-amp fuses, just for a little safety. The 200 ohm potentiometer. This is the OKR T10 chip. As you can see, it's pretty small. We got a 22 microfarad capacitor to go with it, a 220 ohm resistor to go with the potentiometer, and a 4.7K ohm resistor to act as the pull down for the button. What's interesting here are these connectors. So this is meant to go onto the box of the power supply, and then this plugs into it and snaps into place and locks. So that's actually what I got right here, connected to my power supply at the moment. These will come with the kit, so you can, if you get a decent power supply, you could probably put up to 4 of these boxes onto the same power supply. And just give you a quick look at what I'm working on here. This is my ammo can box. This is a power supply I ordered off Amazon. I think it goes up to 240 watts, up to 20 amps. So that will be good for 4 of these OKR boxes. And you can see these ports will just mount straight into the box here. I've already drilled some of the holes, and that's what that'll end up looking like. We'll have a power inlet for it and a master switch. It's rated up to 20 amps, so it'll be able to handle this power supply. And then, since this is an ammo can, get that threaded on there. This is going to be loud. It'll close up like that. And we'll have 4 of these mounted across here. So that'll make for a pretty interesting vape station and table piece, I think. But other than that, we'll get started building the pass-through device. Okay, welcome back. So now we're going to work on drilling out the box for the pass-through. Again, just a reminder, this is what we're building today. And since I shot the last video, I got in this vinyl braided sheath, which is kind of cool stuff. It's expandable. So you can thread your wires through it, and it just offers some protection, keeps the wires together. Looks pretty nice too. So we're going to work on getting the box drilled out. You have to drill a hole for the button, the 510, potentiometer, and one out the bottom for the grommet and the wires. And then kind of file out this area for the voltmeter. So let's go over the tools here. This is pretty simple as far as tools go. Bare minimum, this is what you need. These are, I forget what they call these, stepped drill bit. And it has several different measurements here, and they correspond to the ones available on this cutout sheet that we got. Should probably include in here a pair of scissors, but that's pretty obvious. So you just stick this in any normal drill, and it'll tear through the aluminum box pretty well. I've had this for a while, and I've drilled hundreds of boxes with it now, so there's that. Just need a small drill bit, doesn't matter really what the size. That'll help us drill out the area for the voltmeter, and then generally you can just kind of knock out what the area you drilled it out with. The other two things are some cheap files from the hardware store. Find if you look in like the bargain bin, you'll get like a set of these for like $5. You want a flat one and a square one. And the square one is for cleaning up the corners, because the ridges on the flat side just really don't do the job. So there's that. And we'll cut to the next part. So first off is cutting out this drill sheet. I made these in a scalable vector graphics editor, and the other video I've made showed you how to like glue these on. It's not entirely necessary. You can also use a hammer and a punch, but if you don't have that, just take a glue stick, apply a bit to the box, and then you can stick these cutouts to it. And just cover it in some clear packing tape, gives it a little bit more sturdiness, and you can just drill right through it. Now what's interesting about these templates is there's a couple things to note about them, I guess. You can see here the holes are kind of off-center, and let me open this up here. They're off-center for a reason, and that is so when you drill them, you're only lining up the template with just the box itself, not the lid. And so when you finally get them in place, the buttons will be centered for the entire thickness of the box, instead of being offset a little bit. It took a little bit of math to figure that out, and if I had a better program it wouldn't have been so hard, but that's the reason they're kind of offset like that, and why they make good drill templates. So after getting these cut out, since they're just one hole to drill, I use the hammer and the punch just to mark the place, and then drill them. There's no reason to glue them all on. The only one I end up gluing on is the one for the voltmeter cutout. And I should also note, if you don't like the placement of any of the holes or whatever, I've hosted the raw SVG graphics, and that means you can open up the files and edit them yourself and move the stuff around. Like for this, the voltmeter is just kind of like in the center of the box. I thought it was a good place to put it, but you could put it on any of the sides you wanted, or really any customization you want to do. Other thing to note about these diagrams is you can see here I'm cutting outside of the lines. All the lines are included in the dimensions, so you want to cut to as close as possible to them without actually cutting the line, so you can get good measurement. This will all go with the pass-through kit that I'm selling for these. Will include all of the parts that I listed before, and that black nylon sheath. There'll be 5 feet of it in the kit. So you can make it shorter if you wanted, but I think 5 feet's a good length for these pass-through devices. Basically, it could sit on your coffee table and You could vape comfortably from the couch. Alright, almost done here. Now, part of the trick to these templates is lining them up correctly with the box. So what I've done here is you can see these vertical lines here, the dashed ones on the ends. Those actually line up with the inside screw posts. So you can just kind of get it all situated. And then move this over here. You really want to make sure your worktop is clean so you don't scratch up the powder coat on these. So I got those lined up. The lines are right on the screw post there. And just hold that in place. Put the punch down on the cross and give it a tap. And then I don't know if the camera is going to catch that or not, but we got a little divot there now. And you can just move around and do these for each side. So we'll do the other side. Good mark. Now the top has the wider hole, the 7/16, and the bottom has the 3/8. The 3/8 for the bottom will fit the grommet that comes with the kit, and the 7/16 is just enough room for you to get the 510 connector in. And it's not small enough to tap. If you want to tap the hole, and I don't know why you would, but you'd want to use a 3/8 inch hole for this one. That's on the top. I'll do the bottom. Consequently, these drill marks are in the same exact place actually, so you could use the same template for the top and the bottom. Alright, so we got all our sides marked, top, left, right, and bottom. And from there, I usually like to put the lid on it. And one thing I didn't mention in the tools is having a nice vise. You can see here, this is just a standard table vise. And I bolted it down to a piece of 3/4 inch MDF. I think the two pieces I have for this, the soldering one that I have and this one, was like 12 bucks, and I had Home Depot cut it in half for me. So if you want a good work surface, it's a pretty good candidate if you ask me. I use painter's tape on these boxes. It doesn't mess up the powder coat at all, and it's also waterproof if you ever have to do any work with that. But there's that. And then just to keep the vise from messing everything up, I got a couple slices of cardboard here. This vise isn't anything major, but it really does help a lot. So we're going to do the fire button first. One thing to note about the parts that go into this, both the fire button and the 510 connector, and the grommet for that matter, have a flange. So it will cover up any imperfections we make when we're drilling those holes. But the potentiometer does not have a flange, so we got to be real careful when we drill that. And as always, wear safety glasses when using a drill. So I'll get that set up here. And this isn't going to be a very good camera shot, but I'm just drilling a hole. Alright, so something to note here. I marked the 1/2 inch depth on the step drill bit. And the other thing to see here is, like when I was talking about with the flange, you can kind of see, since the drill bit has like these gouging areas, it'll start to drill the next size hole if you're not careful. And that's fine for these parts with a flange because it'll totally cover it up. But you got to be careful with that with the potentiometer. So I'll put that back. Get rearranged here. Always clean off the vise, brush it out in between drills. Otherwise you risk messing up the nice powder coat on these. Should be kind of a shame. Next we'll do the top. And that's going to be the 7/16 hole. So the last one for the fire button was a 1/2 inch. As is helpfully marked on all of them. And I'm going to adjust the camera. See if I can get that up a little higher. Alright, that's the 7/16 hole. I think that got a little off center, but that's okay. Now this next one is where we have to be careful not to over drill. The potentiometer takes a really good fit with a 1/2 inch hole, so that's what we'll do. And let's see here. That was pretty good. There's probably still going to end up being a little silver ring around that, but we'll call that close enough for government work. And the last one would be the 3/8 inch hole for the bottom. Now, the kit comes with the 3/8 inch grommet. I'm using, I believe this is 14 gauge wire. So that grommet can fit 2 of these wires and the vinyl sheath. So it's a bit tight, but it's a good fit. And there we go. So that's the easy part. Next up, we're going to cut the hole for the voltmeter. And that's mostly just going to consist of drilling out a bunch of holes, and then we'll file it down. Alrighty. Clean up my workspace a little. Okay. So that's pretty much centered for the box. Again, if you want to edit the files, go ahead. You could potentially put it on the side here without too much issue. Although when we do run the wire in here, I'm going to show you how to knot it so it doesn't pull out again and not crease the wires any. So that might constrain a little bit of the room here, but if we look, if you want to plan any of this, I'll open up this box and show you here. I have to say, since this was the first one I built, it did end up being a bit of a jumble of wires. But since this is one of those boxes that doesn't have the magnetic lid on it or anything, I don't think it's a huge issue. So we got the wires running from the voltmeter. That right there is actually the OKR T10. And then some fuses, and there's that big knot of wires right there. And then the other wires run to the switch, the 510, and the potentiometer. So there's quite a bit of room in here. If you've seen the other Raptor video, without the battery sled, I think a Raptor could fit in here just fine. I don't actually have any of those wired up at the moment, or I would show you. Let me just get a couple screws in this again. So. Another trick I found for screwing down these lids is if you want them to be nice and flush, do opposite corners, and that will help the box align itself. So I'll just get those done. And we'll move on here. Okay, next up, I just use all-purpose glue stick from Elmer's. The glue isn't on there for very long, so it doesn't harden or anything. And I just wash it off because it's usually still kind of wet at that point. But what you want to do is get a good, nice layer on there. And this one, there isn't really any trick to lining it up other than using the edges. Should be a pretty good fit. Overhangs a little bit, but you just want to make sure it's squared up. Otherwise, the voltmeter box will look funny. And then the only other trick is getting some packing tape. And I just wrap it right over where the voltmeter is. And that'll keep a nice clear area for us to drill. Just to keep the bottom of it safe while we're working on it, just use some of this painter's tape. Make sure it's all covered. Okie doke. Get the cardboard shims back in here. So again, like I mentioned before, the way the program works that I draw these diagrams with, the dimensions are included in the lines. So we're going to have to basically file out the entire box for the voltmeter, which isn't too hard. First thing we're going to start with is drilling some pilot holes. And this is just a 1/8 inch bit I'm using. So that'll do the trick. And you want to get it inside the box. Really don't let the bit walk too much, or you'll end up having some unsightly notches where the voltmeter is. So we want to be inside the box here. I'm just going to go through these real quick. Alright, so that's kind of part of the problem of drilling them too close together or not far enough apart. Just gently tear that out there, so you can kind of see what happened. So there's still a bit of a chunk of metal there. Otherwise, those are all pretty well drilled out, and you can knock this out without much issue. So from here, it's just a matter of cleaning it up with a file. I think I'm going to stop talking and just get this done, and maybe throw in some hints along the way. I guess the main thing is rough it out with the flat file as much as you can to the lines. But try not to do the corners with the flat file, because you'll end up with some uneven rounding and it doesn't look very good. And then you can clean up the corners with the square file. And that's not good. Another important thing to keep in mind is, just going to fix that a little bit, is it's really important to keep the file up and down. You don't want to go in an angle, and just try to keep it clean. File evenly, and as you're filing, the file will actually take off the paper in your downward motion, so it'll eat it away as you get it all fixed up. There might be some people out there with a mill. You could certainly do this a lot easier with that. My drill press really isn't capable of that, so I just kind of stick to the old school method. Alright, I'm going to pause the video and come back, because I can't really do this with a camera in the way. Okay, when you start to get to this point, the box is pretty well smoothed out, but we know it's not big enough yet. But this is when you can start fitting the voltmeter into it. Now, you can tell it doesn't fit this way or this way, so it's still going to need some work. Part of the difficulty with these boxes is they're not very deep, so the amount you can move the file is pretty small when you do things like that. There's also the point where you want to start cleaning up these corners. Again, you want to keep the file straight up and down, otherwise you're going to have issues. And you can vary the direction that you put the pressure on to cut the metal appropriately. Still checking it here. Doesn't seem like it fits on any dimensions. I think these are mostly, these files are meant for woodworking, but this is just aluminum, so it doesn't matter too much. Okay, so now it fits in laterally, and it looks like might even be a little too loose, but that's not a big deal. Still got to work on the vertical. Still needs quite a bit in that area. Alright, so that fits. You can kind of put it in and then slide it and see if it sticks anywhere. See, it won't go any further that way, so it tells me these corners aren't quite wide enough. This would be a good place for the square file. Had to guess. Nope, still not quite. Alright, so it's pretty close there. The only thing left is to do some sharp corners on it to fit the corners of the voltmeter. Alright, that's almost there. Okay, that's the fit. That's actually pretty snug. So I can take this out, and just gotta be careful pulling that out. Take it all off. That looks pretty bad, but that's just aluminum dust. And pause the video, go wash it off, and we'll come back. Okay, so what do we got here? Looks like I went a little bit too far with that side there. So just keep in mind, you can always take away metal, but you can't put it back. A lot of that imperfection is going to get covered up though when we put the epoxy on this. So it's not too big of a concern. And I'm just trying to test fit this in here. Alright, so we get a piece of paper and kind of see where messed it up just a little bit right there. But the epoxy will fill that in and it'll look pretty good. So that's about that. Okay, so let's start with talking about some of the tools we'll need to solder up this pass-through device. Here's probably the bare minimum that you'll need. That includes a pair of wire strippers and wire cutter combo. These ones from, they're from Hacko. Pretty nice. I always end up using a little pair of pliers like these. These are particularly nice because they don't have any tread on them, so they don't mark things up as much. You'll need a soldering iron. This is my Hacko soldering iron. These are about 90 bucks, but if you do a lot of soldering, they're really very nice because they're digital temperature control. Otherwise, try not to mess up the video here. You could probably make it on a cheapo Radio Shack. I think this is the 40 watt, possibly the 15 watt. You can make it with that. This is solder flux, flux paste. This makes a nice clean solder. It also helps break the tension of the solder so it flows nicely. Here we have some, I think it's 20 gauge wire. Should say on here, but of course it doesn't. 20 or 22 gauge wire is fine for the logic circuits. This is 18 gauge wire. This is mostly what we'll be working with. This is mostly just for like the buttons and the potentiometer and stuff. So that's pretty much the required tools. Some other helpful things are a pair of forceps for jiggling things around and holding pieces and such. I also have these wire cutters. They're good for getting into tight spaces to nip things off. And if you really want to go all super pro special, you can get some automatic wire strippers. If you're stripping and tinning a lot of wires, these things are great. I think they're 19 bucks, totally worth it in my opinion. But I've been doing a lot of this lately, so they save a lot of time, that's for sure. And they also have built-in like crimpers and stuff for some of the connectors that we'll do on the desktop power supply later. The desktop power supply won't be included in this video, but maybe I'll make a post about it or something. So let's see here. For the actual tail of the pass-through device, I have some of this really thick, I think this is 14 gauge stranded copper wire. So this will be what runs to the power supply from the pass-through device. So let's move on to getting everything put together. Okay, first step in getting the pass-through going is kind of prepping the power wires that go to the power supply. What you want to do is I've cut 5.5 feet of this 14 or 16, I think it's 14 gauge wire, and we're going to use about 6 inches of it to create a strain relief knot, and the other 5 feet of it is going to be the cord that goes to the power supply. Now, when we tie the knot, we want the negative end to end up here by the 510 connector. So we want about that much tail coming off of it, just to give it some room to work with inside. So the type of knot we're going to do is a figure-8 knot, and what you do is create a loop like that, so over, and you go back around and up through. Now that is probably not going to be long enough. So we'll get a little bit more slack out of it here. And unfortunately this wire does not bend very well because it is kind of thick. There, that should be plenty. So we're not making a square knot here because that makes some creases in the wires that we don't really want to see. Just try to get these wires to overlap nicely and cinch it down. So that's a good first step there. Next up, I'm going to get these wires nice and straight and make sure they're all together. So just going to run your fingers down them, keep them together, and we'll even them up here. They were even when I started, but the knot took some of it out. And what I'm going to do is tape together the ends to make it easier to thread through the nylon sheath. So otherwise they don't really play well. That should probably do it. Alright, so this nylon sheath is braided and it expands kind of like a snake or worm or something. If you do cut this stuff down, make sure you burn the ends off with a lighter, otherwise it'll start to unravel. So just work that in there. And this stuff comes flat, so try to keep the wires together with the flatness. It'll wind up much better later on in the future. And then you have to start bunching it up. So go back to the end here and squeeze a bit on and just pass it down. And since there's 5 feet of this, it takes a little bit. The reason I chose this stuff for the cabling is it's pretty cheap, it's easy to work with, and it's a lot easier than buying some specialized cables that have all the wire built in. I suppose if you were to go to the hardware store, you could probably find some power cable or something that would do the trick, but this seemed like the cooler option to me. Alright, so we're almost at the bottom here. And we want this to go all the way up to the top of that knot there. Okay, so now it's at the top. You want to squeeze all the excess out of it. And it'll probably end up overhanging just a little bit. We'll cut that off later. But the main thing we want to do now is get this cinched up with a zip tie. And this will end up inside the box, so we don't have to worry about it looking bad or anything. Get the zip tie up on the wire here. And you want the connector to be at the side of the wire, so it cinches this down good. And then take some pliers, you can roll it, and that will tighten up the zip tie even further. And then you can just clip that off. Alright, that's our power cable. We'll finish the rest of it later, but we'll just put that off to the side. Okay. Next up is the OKR T10 chip we got here. Should find a piece of paper. That'll make it easier to see. Okay, so this chip is kind of small. It was a little tricky to solder these larger gauge wires onto. So what I like to do is just kind of splay these pins out a little. Now if you hang out on Reddit quite a bit, I believe a guy Iron Lung Vapes or something, he started selling these OKR T10s in a breakout board, which I think is a fabulous idea, honestly. The package that it comes in is pretty small, but you might have a little bit of a trouble fitting it into a box with battery sled in it. Fortunately, with the pass-through devices that we're making, that's not much of a problem. So I'm just kind of like bending these out just a little bit to make the pins easier to solder each individual wire to. And that's pretty close. So I fudge up the pins here. Given how small these pins are, they are rather stiff. So I'm just kind of splayed out a little bit now. First thing we're going to do is solder the 4.7K or 1K resistor, depending on what designs you look at. This just keeps the chip from automatically firing. If I understand these power boards correctly, they're normally in an on state and they need something to interrupt them normally. So that's going to go from the middle pin here to the right pin. These are numbered 1 through 5 going that direction from this view. So I'm just kind of bending the resistor here to fit that kind of configuration. Kind of ends up looking like this, I would say. I swear the last time I did this it looked a lot nicer. Okay, so that's far right pin to middle pin. And just bend that out a little bit further here. And that about fits. Okay, so next up we bring in the solder, or the solder flux rather. And we'll just go ahead and apply some of that to the middle pin and the right pin. And here's where the forceps come in handy. You don't really want to hold on to a resistor while you're soldering it. That's how you burn your fingers. Alright, looks like that got on there. And that one did not. And give them a wiggle test. Looks like it's good. Here's where these nippers come in. They're pretty handy for getting rid of these extra leads. Let's see here. Next up we'll put the ground wire on, and that's the middle pin there. And get one of these going. Just using the, I think this is 18 gauge wire for this. And as like my other videos, this is going to be a lot of me cutting, stripping, tinning wire. Not the most interesting thing in the world, I have to admit. All of these wires do not need to be any longer than what the box is. In fact, they'll probably get cut down significantly more than that, so don't worry about cutting them too short too much. Just trim a little bit of that off. I'd say these steps for soldering up the actual board itself are probably the hardest part. Not nearly as complicated as getting a Raptor going. Unfortunately, I think I just soldered this across 2 pins. Did I? Nope. That looks pretty good. So I'll go ahead and throw some heat shrink on that. If you do a lot of heat shrink work, another one of those tools that is useful is a heat shrink gun. Totally not necessary, but you really don't want to be waving your lighter around under these things trying to shrink them. It's much safer just to use a heat gun. Alright, that is way too small for that. So I use some of the bigger stuff and hit it. Okey-doke. Next up, we want to do the V in and V out. Those are pretty easy. Those are the ones to the left and right of middle, so that would be 2 and 4 respectively on the diagram. And again, these wires don't need to be too long. So V in is where the power comes in, and V out is what connects to the 510 connector. That would make this V out right now. Jiggle that around. Good enough. And get that one about as long. And just to make this all a little bit easier, trim it down a little. This one I'm going to put on the other side, I think. That'll be the V in, and I'll just hit that with some heat shrink tubing. Keep these all nicely insulated from each other. Alright, next up we can use some thin logic wire, and this will be one of the wires that leads to the fire button. And it's going to go on the right side here to pin number 1. Pushing the fire button eliminates the resistance from the circuit that we put on with that resistor, and basically triggers the whole thing. So that's what this will be. The other side of the fire button will just go directly to the positive node, or the positive power wire coming in. So I'll just lay that up there. Add that on. And then on this left-hand side is where the 220 ohm resistor is going to go. This is what the potentiometer connects to. I like to put it here just because it's a little bit simpler. You don't have to worry about breaking it as much. So we'll put that on. If you haven't seen my other videos, these helping hands I have here, I made these myself actually. Originally I ordered all these arms from someplace on Amazon, but I later discovered that SparkFun has a pretty nice kit that comes with all the alligator clips, the arms, and some screws and washer assembly to hold it all together. Which is a pretty good deal because I think they're only like $1.50 each. So if you want to make one of these, all this is MDF and some epoxy in these arms with some holes drilled in the MDF. Pretty helpful if you ask me. Obviously I use them to hold parts, but the other thing I do is use them to steady my hands, which is kind of handy, if you will. Pardon the pun. I don't have the steadiest of hands, so that's kind of important to me. There's probably a good reason why I'll never be a surgeon in my life, but I can live with that. So we're just going to make a lead coming off of this, or actually no, that's going to go somewhere else. So we're just going to let that sit for a second. I'm going to throw a little bit of heat shrink on that trigger wire, and we're going to move on to some of the next parts. So hit that. Alright, next up is the potentiometer. This is the 200 ohm pot. These are, I think, probably the best one that you can get for this. There's an expensive one, it's like $11, but these are much more reasonably priced. So what I'm going to do here is bend over this middle pin to connect to the right one. If you notice, that's looking at the bottom of it with the middle pin at the bottom. So we're just going to wrap that basically around the right pin, and then I just kind of squeeze them together and push it down a little. Then we take a little bit of flux and dab it right in there and solder that up. That makes a nice good connection. That makes it so when you turn the dial up to 100, the voltage goes up. If we wired it like they normally would, it would be the exact opposite. So for these purposes, we're soldering the wiper to the right pin. With that done, I'm going to trim off just a little bit of that, and I'm going to solder a black wire onto that. This wire will end up leading to the ground, which is a little bit easier to work with than the Raptor, which has all its own trim wires. just trim a little bit off that. Again, these wires don't need to be very long. It's going to be a black one on the two of them that are soldered together. And there we go. Put a bit of heat shrink tubing on that just to insulate it. And then I'll use that red wire that I cut before, and I'll trim that one down too. Alright, not the best solder job there, but it'll do. And a little bit on there. Now that red wire is going to connect to the resistor that we put on here. So first, swap these out. And probably trim that down just a little bit. Strip off some. And tin it up. Okay, so we want to put a piece of heat shrink tubing on there that'll cover all of that. And of course we have to put that on the wire before we solder it on. I've not done that plenty of times. It's always annoying to have to unsolder your work just to get it properly insulated. There we go. And get that in place. And as far as the OKR board goes, that's all done. Just like to squeeze these wires back together a little bit. And we'll get some heat shrink tubing to go over that. About that much. And it's a little bit of a tight fit, but squeeze it on there. And I like to get this all the way down so it covers up some of these wires pretty well. Just kind of reinforces them and makes them harder to bend and break off. There we go. About like that. I'll leave a little bit on this end so we can pinch it shut. Get a nice little package with that, and just kind of close that up. So that's the potentiometer and the OKR T10 with all the wires coming out of it. What are we going to do next? I think I'm going to stop the video because it's going to shut off here automatically soon. Okay, so this is probably as good a place as any to do some quick epoxying. The voltmeter that comes with the kit, and remember from the previous video we cut out this little window. Usually with the box mods I just do that all in one go, but I had some problem with that, so I figured out a trick for it. So we're going to mount the voltmeter here straight into the lid. Start off with I cut off these tabs, and you do got to be a little bit careful. Some of the voltmeters are different, so you don't want to be cutting any traces when you do this, so just be a little conservative about it. They do just snap right off. Like this one has a little transistor or resistor or something right there, so we don't want to get too close to that. And that comes off. So the first thing we're going to do is actually glue the voltmeter to the lid, and then we'll fill in this part of the cover of it. Some people like to use like clear plastic screen protectors or whatever. I found the epoxy works just fine, in my opinion. So these voltmeters come with a protective layer on the front of them. I'll make sure to pull that off. And there we go. Next, first thing, grab some tape. And I put it over the opening. So that creates that sticky surface there. Now you may or not have these craft sticks. Anything of like that thickness will work for this. But what I do is drop them on the floor. So cut off a couple of small little pieces like this. They have to be less than that width there. So that's probably too small or too big. And these will prop up the voltmeter while it's getting epoxied in place. So just stick those down. And there we go. Make sure the dots are on the side that you like, although this is pretty much centered, so you don't have to worry too much about that. And that'll allow the voltmeter to kind of go into the slot, but not all the way. And then use my helping hands here, hold the wires out of the way. Now for all my stuff I use, I should have mentioned this at the beginning, epoxy. This is Bob Smith Industries. I like it because it dries clear, it's pretty solid when it does dry, and it's cheap in these 2 large bottles. If you don't want to go that route, you can get like DevCon. I like that stuff a lot, and you can get it in smaller tubes. The one thing I would suggest avoiding is Gorilla Glue. I don't know what it is about their epoxy, but it seems kind of rubbery after it solidifies, and I don't think it makes for a very good cover for these voltmeters, or a really good epoxy as it is. So we probably want something smaller than a dime. This isn't going to take a lot of epoxy to do this. So 2 globs about like that. And these wonderful craft sticks. I use them for applying all my epoxy and epoxy related chores. This is the 5-minute stuff, so you pretty much gotta do what you're gonna do with it quickly. And basically what we're trying to do here is just glue the voltmeter itself. We're not filling in the face of it yet. Just glue the voltmeter to the lid. And the second step will fill in the face of it. Fortunately, this stuff settles pretty well. If you mostly get it in the right spot, it will do the job for you. That's pretty good. This kind of looks messy, but this will be screwed in and hidden from view. So I'm going to let that sit off to the side. And we can continue on soldering up some parts here. Next up, make sure we got these right. So, potentiometer, check. This wire, this is the front of it, so that's how we started with it. This one's going to go to the 510 connector, and this one will go to the fuses. So next up we'll do the 510 connector. 510 connector that comes with the kit is the Fat Daddy Vapes extended version, and that just means it's got this longer shaft on it here. I like these more because the regular ones, they only had like a couple threads that you could get going, and with the thickness of the Hammond boxes, it kind of made it hard to get all put together. So what I did here is I unscrewed the positive pin included in its Delrin connector. Now when you take this apart, you got to be careful. There is this ring. There's also a little rubber washer and a tiny spring. And if you lose those, you're fucked. It's kind of a shame to throw away basically a $6 part because you lost a piece. So don't do that. Moving back over here. Oops. And I lost my camera stand here. Okay, here's how I do the 510 connectors. First is going to be putting the pin itself into the holder, and then we're going to strip off a good bit of. You want this kind of long, so it's going to be pretty isolated from any other wires or anything touching it, so we don't have to worry too much about exposure like that. But we're going to tin up the connection wire. Nice and good. And then we're going to take like a pick or a toothpick or something and take a glob of the flux and put it inside the pin. Wipe that around good. Try to get any of the excess off the outside. Wherever there's flux, the solder likes to flow too, and you really don't want solder flowing around on the inside of that pin, or the outside of that pin rather. Next, we have to put all of our parts on backwards, so the ring goes in first, and that's the part that screws into the Delrin connector. And then we put the washer on. Bing. And then the spring. So that's all set. And then I like to hold that right there. So what you want to do is position this so the wire is inside the pin. Like so. And there is still a bit of exposed wire there, and that's going to help us. This is the easiest and most surefire method I've found for connecting these pins together. So what we're going to do is get a glob of solder on the soldering iron and touch it to the wire, and basically just let it cook all of that flux out of the pin, and it will suck up the solder. And you'll hear it bubble and just let it solidify. Now that's going to be really hot, so don't touch it. And the alligator clip's probably going to be pretty hot too. There we go. And later on we'll solder one of those voltmeter wires, the red one, to right there. So we're going to leave that pretty much as is for the moment. Next up, we'll solder on... No, we don't want to do it to this one. We'll move on to the fuses is what we'll do. Okay, so these are two 5-amp fuses, and one side of them is going to go from the power into, let's see here, yep, into the V-in for the chip. So I just like to bend these kind of towards each other when they kind of intersect each other, and that'll make it nice and easy to solder that wire onto it. So I just trim them down, about like that, and then clamp them up. I want to keep those wires pretty close to each other, and we'll strip off the V-in here. Tin it up. And we'll put some heat shrink tubing on that. Grabbing the small stuff. And we want that to make sure it covers all of that, so we'll slip that down on there. And put that kind of next to that. That scratching noise you hear is my cat trying to get my attention by being annoying. And now he can be internet famous for it. So this is a pretty heavy connection to make. I make sure there's good solder on all sides of it. It looks pretty good. And we'll just slide that down. There we go. Now that side, we're going to put one lead wire coming out of that, just a thin little logic wire, and the other side is going to go to our power cable, which we'll get to in just a second. Let's see. So again, just kind of bend these in towards each other. Just found that's the easiest way to get the big wire on them. My cat is going full retard in the background. The joys of owning a cat. Okay, so back to our power cable here. We don't need all of this red. I would say probably cut about half of it off. And sometimes those automatic strippers don't pull enough off. So that should be pretty good. Tin that up. That should be good. Kind of put all that over there. And we're also going to get a little red wire, logic wire set up. And this will be the other side of the fire button. So unlike some other designs, We don't have a lockout switch in this one. I guess you could add one. Just put it in line with the fire button if you wanted. But since this is a pass-through, I didn't really think it was necessary. I don't know. Somebody can feel free to tell me I'm wrong in the comments. So we got that ready. And I just want to grab some heat shrink tubing. Cover that all up. So what we're going to end up doing is feeding these two wires through this piece of tubing, just to make sure they both get covered up. I've actually had some trouble getting that to fit before. So I'm just going to say screw it and get the really big stuff. This is probably totally overkill, but I like making sure the wires are insulated. Okay, so two wires here, one going to the power cable, one going to the fire button. And just for sake of evenness, we'll pull that up. Grab some flux here. And if you want to make this easier on yourself, you could probably solder these together before you do all this, but who doesn't like doing things the hard way? Alright, I think I got that reasonably aligned here. Probably end up burning my thumb because that's going to get hot. That's good. Real good. Alright, somehow by some stroke of luck I managed to do that right. And there we go. Next up we should probably measure this all against the box. Usually end up kind of bending this back like yay, and that kind of gets piled onto it. All these black wires are going to end up leading to the ring for the 510 connector. So it's going to be kind of like a combination terminal and everything else. And these two wires go to the fire button. So we're almost done here. I'm going to stop the video for a minute. So in the interest of getting this video done, I think we'll finish up by soldering the voltmeter connections into place. get the 510 negative connector going, and get the button wired up basically. And then the last thing I'll do is do the epoxy for the screen. This is hardened by now, so that should be fine. Normally I would do the screen now. I guess it doesn't really matter which way you do it. Okay, so let's get this roughly measured out here. That's going to end up somewhere around there. I want a little extra room for this negative wire to get jangled around. So I'm going to guess somewhere around about there. Cut that. It's equally going to end up in about the same spot, so we can clip that. And we'll just take a little bit off there. My cat is being an idiot again. It's a common theme for him. Let's get these all stripped down. Tin these all at once. Trying to scoop up some flux here, but it's not working. Okay. Clear off some of my workspace. We're going to end up soldering all three of these wires to that ring. Probably get a little bit crowded, but I think it'll work fine. I know it'll work fine, I've done it before. The only real trick to soldering onto these rings, don't bother bending it. I started off doing that, it's not really worth the effort. Just smear a good bit of flux on here and make sure some gets in that hole. Found that's really what keeps the wire on there. So I just kind of do these in a layering method. I keep these out of the way here. So I just lay it on flat and throw a big gob of solder on it basically. Yeah, that's pretty well on there. Probably want to stabilize this now. Take some of the tension off of it. And then we're just going to start stacking up these wires. You can end up with some bad connections if you don't do this very well. Just be careful of that. Use a lot of flux. You can always clean it up later with like a Q-tip or something. It does get kind of sticky. And that is definitely one of the things that can happen. One of the downsides to one of those cheap Radio Shack soldering irons is you might have some trouble soldering like this big of a lump of metal. They just don't put out enough heat to be able to do it. That's kind of why one of the reasons I like these Hakko so much is they do not lack in that department. So I'm just going to tack this one on the side here. Burn my finger a little bit. There we go. Part of the fun part here is trying to carefully attach these voltmeter wires. If you get the new voltmeters I have, you can actually unsolder these wires and attach your own if you prefer something with a little bit more gauge to it. It's not a terrible idea, honestly. If you build a Raptor with these, it's kind of nice because you can really shorten the wires on them. Should note that you won't find this exact type of voltmeter on Amazon. I special order these from China. I guess it's not a particularly special order, but I haven't found them anyplace else. Alright, so that's a nice big glob of solder everywhere. Next up, we'll attach this positive wire to this piece. Now, one trick I found for this is if you screw the Delrin connector in, it'll keep this brass piece out of the way while you're trying to solder that wire. Be very careful not to strip the threads on that Delrin piece. The plastic is really soft, so it's pretty easy to do, and you definitely don't want to clamp down on that plastic piece with the gator clips or anything like that. Best bet with a little voltmeter is probably do kind of like an angle on this larger gauged wire. And I think I got a pretty good solder on there. That is essentially all of the soldering. Now it's just a matter of squeezing it all into the box. So I'm going to kind of clear up some of this stuff and then we'll do that. There is one little more dab of soldering we have to do, so I'll leave that on. Okay, so we want to take the grommet out, and pretty much means we have to start preparing this. So the wire ends right about there. Probably want, I'm going to say like an inch of the wire past the sheath. So I'm going to clip that off. Now this is fraying a little bit, but I'll hit it with my lighter. And it will kind of stop that. Don't breathe that in, that's bad. Now we're going to rewrap the tape here. And we're going to include the vinyl in it so we can get it past the grommet. Again, double check that all the slack is pulled out of the vinyl. In reality, I probably should have done that before I clipped it like that. So you can kind of see how much that grew right there just by pulling some of the excess out of it. There we go, we'll do that again. And let's see here. There we go. And just thread that onto the grommet. Get past the vinyl there. Or no, wait, I don't want to do that yet. I forgot. So we're going to thread it into the box first, and remember that goes in the small hole down at the bottom here. And this is getting all tangled up nice. So that's going to come all the way up to the zip tie, and then we can put the grommet on. Now the only trick I found to getting that grommet actually in that hole is taking something blunt and just kind of stuffing the bottom edge of it down in there. You really want to be careful not to mess up the nice powder coat job. Alright, almost there. There we go. So that's in place. Gonna end up breaking those off. So just protect those voltmeter wires a little bit while we're screwing around with everything. I'm gonna cut off a piece of tape and just tape them down. Lest we end up repairing those later, which is not very fun. Okay, for the voltmeter, probably the easiest way to deal with, or not the voltmeter, the potentiometer here. I'm just going to bend these wires a little bit. Just at a right angle to the bottom of it. And take care of that one. That'll keep them out of the way of the 510 connector when we get this fully assembled. So let's get that all out of the way there. And this is probably one of the first things you want to get in. It takes a little bit of leveraging. The potentiometer is pretty tight fit in the 1/2 inch hole. So much so that sometimes I just leave these unglued. They can push out so it might be a good idea to put some epoxy around it, but they're usually such a tight fit, it's not a problem. You can take a file and loosen these holes up a little bit, but I really don't suggest it. Just makes it easier for it to fall out. So that's pretty flush. There we go. Okay, hopefully we haven't destroyed anything else in the process. All looks pretty good. The 510 negative lead here, we're going to bend these wires so they're kind of like straight back. And that will give it room for everything to connect. And what we're looking for is those to go down into the corner there. And we want that to line up. So I'm going to have to be a little bit more forceful with it. Bending the ring, not a good idea. Ow, that's really playing hardball. So the problem here we're having is used a lot of solder there and it leaked up into the wire, so it's making it very difficult to bend. What I'll probably end up doing here is putting it on the table and kind of forcing it. That'll probably be close enough. Test with the 510 connector. Yeah, that'll probably work. Okay, so just to make assembly a little bit easier here, take the washer off the fire button and thread it through the wires, or thread the wires through it, and then get those to go out the fire button side. That'll just make that easier. Next up is the, wow, that is not a cut 510 ring. Huh. I'm gonna have to email them about that. That's kind of strange. Crazy. Get the real locking ring here. And these are notched, so that little notch there has to line up with that. And they kind of snap into place. To keep them together, I just throw a little bit of tape on. and that'll just make everything easier while we're assembling it. So get that threaded in, like so. Just want to get the nuts started on it. And then so we probably should have cut that a little bit shorter, but it'll work fine. This is the best tool I've found to assemble these 510 connectors. I gotta do this pretty quickly because both my battery is dying and the video time is running out. So we want to get the Delrin started. And get that lined up. Actually, in this case, I'll just unscrew the Delrin. Remember, these things are really easy to cross thread, so it's probably better safe than sorry. Just screw that into there. Do. You can get that screwed in most of the way, and then put the positive pin in, and if you just hold that brass sleeve up against that while you turn it, it will screw it all together for you. And at that point, should be pretty good, and then you can just tighten it up the rest of the way. There we go. Alright, last but not least, the fire button. Just trim these wires down a little bit to keep the jumble inside down. And trim off a little bit. Grab my screwdriver here. Get those threaded in. There we go. And you retract that back in there. Found the bend radius, if you have the wires going in that way into the switch, kind of works the best here. Just kind of pull that all back. And get the nut on there. Finger tighten it down all the way. If you watch the Raptor video, you can kind of tell how much easier this is. It's a smaller box, but there's a lot more room to work. Break something doing this. There we go. Now we just kind of want to situate these parts so they all kind of sit down in a nice fashion. And peel that off. And that's pretty much that part of it. Let me grab the screws. I'll tighten this down. Normally I would glue that potentiometer in place, but we don't really want to wait for glue to dry for the purpose of the video. You can just slather the epoxy around the potentiometer, just like we did with the voltmeter. It'll hold it sufficiently. So I'll get that all done up. Alright, so jumping ahead here, let's go to the other end of business. We got 3 minutes to do this before the video quits. We want to strip off. First we want to even these ends up. And we do that just by pulling this all out. Those are pretty close. For the connectors that come with this, we want pretty good length stripped. So we'll do, what's that, probably like a 1/2 inch or something. And just get some flux on there. I tin these up because it seems like they go into the screw terminals on the connector a lot easier. Alright, there we go. Now here is the loudspeaker connector that comes with the part kit. It's got 3 parts here. This is the part that plugs into the power supply. This holds all the wires and grabs them, and this is just a cap for that. So we'll loosen up these 2 screws here. I don't know how well the camera can see that. And the one on the right is positive. So we're going to thread the blue cap on first, and then the claw thing, so the claws are pointing away from the wire ends. And just to double check, we're going to get all of the vinyl down to the end where it should be, and thread all that back on there since it came off. And that. And I'll just put these screws, or these wires, into their little bays there, and tighten it down. And that alone holds the wires pretty well. But again, just to double check that the vinyl is as tight as it can be, we'll pull it all down. And this little plastic thing kind of sits into these markings, these little notches here, and then this blue thing screws down on it. So you just want to make sure all the vinyl's down in there, and you can start tightening it up. And this cap will end up squeezing those teeth together, and it will clench on the wires and on the vinyl. Now when the video comes back, I'll finish up the epoxying and we'll be done. Last and final step we're going to do here is applying epoxy to the face of the voltmeter. Might be a good idea to just grab some rubbing alcohol and a Q-tip and just clean any oil might have gotten on that off. Just makes the the epoxy stick better, I guess. It's mostly a precautionary thing, but good idea to make sure it's clean. For this step, I'm going to use a heat gun to get all the bubbles out of the epoxy. If you don't have a heat gun, a hairdryer will work. Otherwise, you're just going to have a lot of artifacts in the epoxy covering the voltmeter there. So, squeezing out probably, I don't know, a little bit more than a dime, maybe a nickel of each epoxy here, the hardener and the actual glue. I think that will be enough. So when you mix it up, yeah, there's a lot of air bubbles that get into it. The simple trick is just you heat it up with a heat gun a little bit and it pops them. They're all nice and mixed up. Looks pretty good. So I'll goop a bit of this onto the voltmeter face. And this is mostly one of those kind of experience things. I think I've only ever put too much on once and kind of overflowed the edges. So you don't really want to do that. The reason I'm taking my time here is when this stuff is just freshly mixed up, it's very viscous, or very fluid and thin, so I don't want to drip it all over the face of the powder coat. This particular epoxy, if that does happen, you can usually scratch it off with your thumbnail without damaging anything. So now that I got some on there, I'm going to take one of these other sticks and just kind of drag the epoxy out to the edges to break the surface tension of it and get it to the corners. It's mostly just stretching it out. Here's where you usually get a good idea if there is enough epoxy down in the groove there. And from the look of it, probably use just like another drop or so. You can just kind of dab that in there, and it will slowly spread out. I'm going to take the heat gun. I don't know if the video can see it or not, but it's slowly popping all the bubbles. And I think that is about perfect. If you remember when I drilled this out, there was that little imperfection on the side, and it looks like the epoxies flowed into that pretty well. So, no worries there. I'm going to put that off to the side. And we can talk about this thing. Then I'm going to pause the video and reposition here. Okay, so why did we make a pass-through device? Well, because we have a desktop power supply. And that's basically what I've made here in this ammo can. You can see the ports along the front here. I kind of introduced this at the beginning of the video. Since I shot that part, I finished the power supply. So we'll pop this open here. Just let that sit. So here I've finished 2 of the boxes already, and they store in here. I'm still working on how to fit everything in here, but that'll come in due time. So if we take one of these out, it's pretty much exact replica of what we just made in the video here. 5 feet of cabling with the loudspeaker connector and all that other fun jazz. So what I thought was really interesting about these connectors is they have this spring-loaded switch thing. So it's notched in, and then you twist it, and it's locked in place. So this has room for up to 4. Now if I plug this in the back and plug it into the wall, I essentially have, let's turn it on, a nice pass-through vaping device. And we'll screw my Addy on there. Now this is only a 50 watt device compared to the regular 120 watt that I use, but I still think it does a pretty good job. Obviously puts out quite a bit of vapor. Just to kind of go through this, I'll unplug it and make it safe. And we can look, well, it's safe anyways, but we can take a look on the insides of this. I'll take off the lid here, put that aside. So here is the foam insert that I made. This is just pick and pluck foam that I ordered. This stuff is split up into cubes, but to ruggedize it and give it this black color that it has, I sprayed it with a can of Plastidip. And this was something I learned from cutting out the foam for my gun case. So this gives it quite a bit of protection, and it seals up all those half-inch cracks, which is kind of cool. So there's that. And then inside of it, I had some ABS plastic laying around, so I made a shelf that fits over the power supply and those front connectors there. And I had to attach a cord to it because I wouldn't be able to pull it out otherwise. So here is the inside of the power supply. We got the 4 connectors, and they all hook up to terminals, which then are bridged and connected to the power supply. The power supply gets its power from the back here. This is just a standard IEC something. It's basically the plug the cords for your computer to use. We have a 20 amp rated switch, and this is a 20 amp power supply, and then a 20 amp breaker just in case anything goes wrong. So I'll also be putting together a part kit for this. It won't include the ammo can or the power supply, but you will have all the terminals, the crimp-on connectors, the switch, the power inlet, and the breaker that'll come with it. So it's all really easy to connect together. And it'll have these inlets, and then each of the pass-through kits come with their own plug. So we'll have a bunch of options there if anybody wants to build something as crazy as this. So yeah, that's the desktop power supply and pass-through. And then this just kind of drops back in there, and the foam goes in, and the lid goes on. So there you go. Thanks for watching. Visit my website, nonameboxmods.com, where we sell all these part kits, and enjoy vaping. Thanks. Bye.